Hello. So in this video we're going to look at the use of trigonometry to solve advanced problems, sort of the pre-calculus level. There's another one on pipeline, you can look that one up, and we're going to do this one. So let's go ahead and read it. So a lifeguard is sitting in a tower and spots a distressed swimmer, as indicated in the picture, which I'll show you next. And to get to the swimmer, the lifeguard must run some distance along the beach at rate P, enter the water, and swim at rate Q to the distressed swimmer. So it looks like this. Here's a distressed swimmer. Here's the lifeguard. They got to run, swim, right, and get to the person. Obviously, they want to take the least amount of time possible. So to minimize part A, to minimize the total time to the swimmer, should the lifeguard enter the water directly or run some distance along the shore and then enter the water? And explain. So what I'd like you to do is go ahead and pause the video. Let me show you the picture again. Pause the video and answer that question. So what they're asking is, should the lifeguard enter right here and go swim? Or should they run some distance, and maybe it's all this distance and then swim, or run some distance and then swim? So which is the best option? Explain why. So pause the video and think about that. So hopefully you've thought about that. And the idea is this. People can run faster than they can swim. So if the lifeguard jumped in right here, tried to swim, that would definitely not be the minimum time. But also, if they ran all the way out here and then went here, that's a lot of time. Because remember, even for just the triangle, 2 legs of a triangle are longer than just 1 leg of a triangle. So even if it's the longest leg, so you definitely wouldn't want that. So there's some what I call sweet spot here, and that's why you've got this theta here. Is, well, at what point do you jump in the water and then swim over? Okay, so that's what we want to find. So what we're doing then, now this is a bit abstract in the sense that you're not given values yet, but they want you to find an equation. So express the total time t that it takes the lifeguard to reach the swimmer in terms of theta d, c, p, and q, where theta is at what point do they actually come in, c is this distance from the swimmer to the shore or the beach. And they tell you P is the rate that they can, run, and then Q is the rate at which they can swim. Okay, so what they mean by this is you have to have T on one side isolated, like with just a coefficient of 1 understood, equal to, and then blah, 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 theta D, C, P, and Q. That's what they want to find out. And then once you have that, in part C, they give you specific values for all these abstract values. So they give you for D, C, P, and Q, and they want you to find out, graph it, and then show you, what are the increments, and set up your table, and find out what's the minimum time, right? Now, obviously, if a lifeguard could do that all in their head, well, they probably should be playing the stock market or something. But anyway, so we've already answered part A. The next part, I want you to pause the video and tell me, how would you express the total time just in terms of words? How do I find the total time? Okay. So pause the video and we'll come back to this picture. Let me go ahead and set up while you're thinking about that. Okay. So hopefully what you'll see is that this is one of those problems that's sort of a classic distance is equal to rate, right, times time. Right. So what I mean by that, let's just do a real quick example, right, just to refresh your memory. Suppose I drive at 50 miles per hour. Okay. Well, if you tell me then, if that's the rate at which I'm driving, then if you say to me, well, now you drove for 3 hours, right? All I have to say is there's 3 sets of 50. So how far have I gone? 150 miles, right? So that's your distance equals rate times time. And generally they write D equals RT, right? That's it. Now in part B, what they ask you for is the time, T. So what we need to do is solve for T. Well, here's T, so T just needs to, T times R just needs to be divided by R, right? So T is going to be D divided by R, okay? So now I'm going to write this in words, and I'm going to say T, total time, equals, here, the distance, now you have two different distances, right? Distance on land divided by what? The rate on land, plus then there's another distance, right? Distance in water divided by the rate in water, right? Now, what happens is they gave us certain things here. They gave us the rate on land, the rate in water, even though they're just abstract. They said you can run at rate P, and this lifeguard can swim at rate Q. So let's plug that in. So that means we have T equals distance on land, right, divided by, and that was P, right, plus distance in water divided by, they gave us this, was Q. All right, so we're getting closer, and hopefully this makes sense to you in words. Now we have to go to the picture and start figuring out, well, how do I figure out distance on land? How do I figure out distance in water? Okay, those are the two things I'm now going to go for. We'll come back to that. All right, so now what I want to look at is how do I find, for example, distance on land, distance in the water. So what I'm going to do is kind of split this up so I can see it. So I want to look at distance on land and I want to look at distance in water. Okay. Now, the distance on land really is, let's see here, the lifeguard running from some point here to here where that lifeguard decides, well, now I'm going to go in the water and then swim. So, but they're giving me, I have to look at the picture and say, well, they're giving me D, which is this entire distance from here all the way to the point where the swimmer is down to the shore. So what I'd like to do is cut out this piece right here, because then if I knew what this was, I'd just say D minus this piece. So let's go ahead and label that. I don't have it, so what I'm going to say is, I'm going to say that this right here, this distance, I'm going to call X, because I don't know what to do with it. So I'm going to just call it something so I can work with it, right? So here's X. So the distance on land is going to be, at this point, D minus X, okay? So what I need to do now is say, okay, I need to find X, and I've got a right triangle. So let's take a look and see, can we figure out that right triangle? So here we go. So here's a right triangle, right there. And what I have is I need X, and here's C. And then what they gave me is this is the angle I'm working with. And I have to know the angle because depending on which angle they give you, that's how you know it's the sides other than the hypotenuse or relative to that angle. So relative to this angle, this is opposite. And relative to this angle, this is adjacent. Okay, so what do we have here? Well, I know that I was given C in a sense, so I have the opposite side and I want the adjacent side. So which trig ratio should I use with opposite and adjacent? Well, you could use tangent or cotangent, but I would go with tangent because it's on your calculator, it's just a lot easier. So I'm going to say tangent of the angle is opposite over adjacent. So I'm going to say now tangent of that angle is c over x. And remember, I'm trying to solve for x so that I can find d minus x. So if I multiply both sides by x, I'll have x tangent theta equals c, and then x equals c divided by tangent theta, which some people would write c times 1 over tangent theta, which would be c times, let's write it here, cotangent theta. All right, so d minus x, hopefully we're not running out of room, is equal to d minus c times cotangent of theta. Okay, so let's just... So we've figured out the distance on land. It's d minus x, which is d minus c cotangent theta. Right? So let's go ahead and put that in there. So distance on land, right? Distance on land, what we found out. Let me lower this a little bit here. So t is distance on land, which is d minus c times cotangent theta. And then we have all divided by p. Okay. Now we do plus. And now we have to find distance in water and divide it by q. So remember, we just did this. So I would say pause the video and see if you can go ahead and find out what the distance in water is, which from the figure you can see is right here, right this side. So go ahead and pause the video, see if you can do that. So if you've paused the video, hopefully what you've done is something like this, right? Here's your right triangle, here's your right angle, here's your theta, and we have, I'm sorry, this is what they gave you. What you want to find out is when the lifeguard swims, he swims this way, jumps in the water and swims here. So what we want to know, is h. So let me go ahead and label that there for you. And that's what I labeled it. You can label it whatever you want. So I'm sorry, you have to find this here, h. So what do we have here? So relative to this angle, this is the opposite side also still, right? And this is the hypotenuse because it is across from the right angle. So what two sides are you dealing with? Well, you're dealing with, you have, and when I say have, it's because they gave you c, the opposite side, and you want the hypotenuse. Okay? So which trig ratio should you use? Well, hopefully you'll use, let's see, sine, right? So sine of an angle is opposite over hypotenuse, and in our case, sine of the angle, right, is c over h. And by the way, here the distance in water is, we're going to call that h, right? So we need to solve for h. Since h is in the denominator, I want to multiply both sides of the equation. So I'll have h sine of theta is c. And now divide both sides by sine theta. So h equals c, right, divided by sine theta, which would be fine. Some people will say c times 1 over sine theta, which is c times cosecant theta, like that. Okay. So there's your answer there for h. So now we just need to put that in our equation. Okay. So we have here distance in water h. H is c cosecant theta. So we have c cosecant theta. And you don't have to write the parentheses. It's up to you. I'm doing that for emphasis, really. Over, let's see, what we already had, q. Okay. So you've actually found now, here, this part. Express the total time t. You've done it. T, understood 1. It takes for the lifeguard to reach the swimmer in terms of all these variables, and that's what you've got. You've got d, you've got c, theta, p, c again, theta, q. That's it. You've done it. All right. So now the third part of the question is, for what value of theta is the total time minimum? Now, obviously, they gave you a lot of variables, so they had to give you specific values, right, for you to fill in, and that's what we're going to do next. So I'm going to fill in these values. If you want, pause the video. Here's the equation, right? plug in these values and then put it in your calculator, graph it, and then when you're doing your table setup, start at 55 and increment by 5, and then see if you can figure out what the minimum time is, okay, and for what angle that happens, okay? All right, so let me clear up some of this, and let me plug some of this in now. So hopefully you've paused the video and you've done that. So, all right, so now I'm going to just plug in values here. So I have, now I'm going to go ahead when I use it in my calculator, I'm going to do D minus C times C divided by tangent of theta. That's what I'm going to end up doing. So I'm going to do T equals D they gave me was 380 minus, and I'm going to do C divided by tangent of that tangent of theta. And the reason I'm doing that is because in my calculator, that's all I've got to work with is sine, cosine, and tangent. I'm going to have to do 1 over anyway. Oh, sorry, C actually had a value, didn't it? 76. Let me put that in there. 76. Okay. And then we have all divided by, and P was 5.1. Plus, and now we have C again, so 76. And I'm going to divide it by cosecant of theta, which is really going to be sine theta, right? All divided by Q, and Q was 1.7. Okay, so in my calculator, what I'm going to have to be careful about is, you know, you do y equals, and then you're going to have to open up parentheses, put all that in there, and then divide. And then it's easier to probably do this because it's easier to understand, so put that in parentheses. Okay. So now what I'm going to do is show you what I've got in my calculator. All right. So I have here 380 minus 76 divided by tangent of theta. And notice you have the double parentheses, right? The first parentheses is just to say it's the closing of the angle. And this other parentheses is to close this parentheses. And then all divided by 5.1. That's this. And now we're going to do that. So let me move it forward. There's your 76 divided by your sine theta, or sine x. Again, this parentheses closes that parentheses, and now divided by 1.7. That's this. Okay. So now what you do is you go to, second table set. And they told you to start at 55, you're going to end at 85, increment by 5 degrees. So that's what I've done. Okay. Now I'm going to go ahead and see what I've got under table. So I'm going to do second table. And when I can see total time 118.65, 117. So it's coming down, 116. Now watch, 116.66 is your lowest time, right? Because it's 0.89 versus 0.866 is smaller. So what happens is at 70 degrees, you have your smallest or shortest amount of time, minimum time, of 116.66. Right? So I would say here, theta is 70 degrees. Time is 116.66 seconds, right? Just double check that. Yep. All right. And that concludes this. Thanks so much for listening.